We're going to solve a problem here now where a vessel typically has water flooded on deck, and you're asked to calculate the fluid GM and then the angle of Loll. Okay, to have an angle of Loll, you must have an initial negative GM after the vessel has flooded. So straight away you must realise that your fluid GM answer is going to be a negative answer. So if you get a positive GM in the answer, you've done something wrong. Okay. So a floating even keel draft of 8.6 in salt water, kg 7.4, and with this midship rectangular deck, 29 metres long, extends the full breadth of the vessel. It's flooded with salt water to a depth of 0.4. Height of the deck is 11.75. Using our stability data booklet, calculate the fluid GM. Well, I think with stability you should start up by saying, okay, well, GM is always km minus kg. Okay, we know that. The km we will get from our hydrostatic tables at the conclusion of working out the kg of the vessel. To get the kg of the vessel, we have to use the table weight, kg, moments to work out our final kg. So that's how we get the GM. So let's forget the km at the moment. Let's think about the kg. We're given our initial kg of 7.4 on our draft, so we can find our initial displacement simply by looking up 8.6 in the hydrostatic particulars. Then we're told we've got this rectangular deck. Well, that should tell you, okay, I've got the length of the deck, I've got the breadth, and I've got the depth of water, and it's salt water. I can work out the weight of the salt water. If you're unsure about formulas, just look at your formula sheet. Weight is volume times density. Okay. Volume times density. Volume, length times breadth times depth. So you would do a straightforward calculation to work out the weight of the water on the deck. 29 by 20.42 by 0.4 by 1.025, 243 tonnes. Now you need the centre of gravity of the water on the deck. We're told from keel to the deck is 11.75, and the depth of the liquid, the salt water on deck, is 0.4. Now kg, the definition of kg is the vertical distance from the keel to the centre of the weight. So the vertical distance from the keel to the centre of the water on deck will be 11.75 plus half its depth, always half its depth when it's in a rectangular shape, and these are always rectangular shapes. So therefore our kg of our weight on deck, the water, is 11.95. When you see the word fluid in a question, fluid GM, you're going to have free surface moments, and the free surface moments are created by the fact that the water is sloshing about on the deck. The formula for free surface moments, LB cubed over 12 times density, gives us free surface moments of 21,092 centimetres. Okay. Now we can do our table to get the kg. Weight, kg moments, weight of the salt water, it's kg, the moments, always plus these free surface moments, of course, when you introduce free surface effects. Divide the moments by the weight, and gives you a final kg of 8.59. From the tables, at that displacement, we can get a km of 8.43. 8.59 from 8.43 means that our fluid GM is minus 0.16. When you get the GM is always km minus kg. So GM is km 8.43 minus kg 8.59. Mathematically straight away will give you a minus answer. So hopefully you're okay with working out the fluid GM. Second part asks you to calculate the angle of Loll. Well, if you've forgotten or you're unsure, as always with stability, you're very fortunate you do have the tables in your exam. So angle of Loll is minus 2 times GM over BM transverse. Okay, so minus 2 times GM over BM transverse. So we know the GM, it's minus 0.16. Well, how do we get the BM? Well, BM, if we think of our vessel, there's the keel, there's the centre of buoyancy, and there's the metacentre. So we're looking for the BM. Well, we know the KM because we just calculated it in our last problem, 8.43. So we go into the tables with our displacement and we get our KB. So from the tables, the KB is 4.56. So we know the KB, we know the KM, we can simply subtract one from the other to get the BM. So once you know which formulas to use, write that down, look at the values you need, and by a process of elimination you can get the values. So it's minus 2 times 0.16, that's a minus sign of course, both minus signs, that becomes a plus, divided by 3.87 tan theta, and it gives an angle of Loll of 16 degrees. Okay, so minus 2 times your GM, two minuses become a plus, therefore the angle of Loll is 16 degrees.